turn off all your gadgets, focus completely here for next 2 hours. Okay, so definitely throughout the course, I'll at least when I'm teaching, I'll need your complete concentration, first of all, right? Second is trust. I've been mentoring a lot of students since last 3 years, and there have been some success cases, some miraculous stories, and then there have been some failure cases also, right? And the cases that failed were mostly around trust, right? Some students who trusted me and just followed whatever I was telling them. Uh, there are miraculous stories, right? So, like one of my students, she was like 4 years gap student, BSc, just BSc. She got in Ernst and Young in the first interview, 8.5 lakhs, right, as a business analyst. So only thing that she did hard work, whatever courses I was giving her, whatever recommendation I was, and she completely trusted in me in the sense that whatever guidance I was giving, she followed that. And within 3 months, she was able to undergo this miracle. Okay. So definitely I want your trust. Okay. I don't want to beat my own horn, but yeah, I have definitely more experience than you guys, a lot of you guys in the industry. So just trust me. Okay. Next, what I'm needed from you is curiosity, right? You learn stuff only when you have a lot of curiosity, right? So uh, everyone should have a curiosity of a child, right? How computer works, how this thing works in computer, how this is going on. And I'm telling you, I'm like almost 12 years experience now, and I'm at a very senior position in this industry now, and uh, it's all basics. It's all curiosity, actually. If somebody asks me, computer science is very difficult. Like, computer science is not difficult. It's very simple, actually. It's just a set of basics that you know, right? It's like car. Car mein, if you know कि भाई engine के अंदर how stuff works, transmission में how stuff works, right? So if you are a if you have like basics of like how car functions, if those basics are clear, then most of the time you can debug like whatever is happening in the car. Engine is not starting, maybe fuel pump is there's some issue with the fuel not going into the engine or air not going into the engine, stuff like that, right? Same thing is with the computer science also. If you understand everything, how stuff works, that's all that you need to know. Even from like even for being like a 20-year experience or being the CTO of a company, still it's the same thing. If you understand the basics, if you understand the foundations, you can work in the industry. Okay, and that's what this whole course is about. Like, I'm going you to take you through this foundational journey, like through uh, like everything in computer science you'll know by the end of three months, and you can actually compete with any BTech, any person in the world. Okay, but for that you need hard work. Okay. Yeah, so today I'll be doing a lot of philosophical talk also in the first class. So don't think this guy is not teaching the course, he's talking about all this stuff, but yeah, that is also important. Okay, for the first class, bear with me. Okay, so the next thing that I definitely need is hard work, right? So I live in Kanpur. Here behind every auto, there's a quotation, एक ही जादू कड़ी मेहनत. If I translate that to English, that means there's just one magic in the world, which is hard work. And that's very true. Uh, luck is there, definitely. But if you are like a hardworking person, eventually luck will also give up. Even if you have a very bad luck, still, if you are keep on consistently putting in hard work, you will break even or break through at some point, right? So definitely hard work is the key, right? There's no substitute to hard work. You'll have to given time to this course. So there's no substitute for that. Okay. Next, don't fear, don't get overwhelmed, don't give up. Okay. So I'm there to help you. This WhatsApp group is there to help you. Whatever doubts you get, whatever questions you get. Okay. So feel free to ask in the group. Okay. So don't fear, don't get overwhelmed by anything. And don't be ashamed to ask that. So there's no bad question. Okay. So don't think, what others will laugh. When I was in college, I used to like ask. I was a person like who used to ask most of the questions to the teacher. so, don't be ashamed of this. Okay, and there's no bad question. Whatever you are want, feel free to ask. Okay, and finally, no excuse is acceptable. So if you now this is the first time I'm doing this deposit thing, because in the earlier batches I've run, I've seen this problem that people don't solve assignments, and assignment is the whole learning. Actually, I'll talk about that in the next part. Okay, so 1 second, somebody's pinging me. Just give me 1 second. Somebody's pinging me. I need to share the Zoom link with them. Okay, so yeah, so I won't uh, uh, accept any excuse, right? So for every assignment you will have 7 days, which is 7 + 24 hours, and every assignment is just few hours of work. So don't give me any excuse. Okay, sleepless, I don't know, do whatever, but work has to be done if you want to learn. Okay, and throughout the course, try to identify like what you are liking, what you are not liking. I'll talk about this again in more detail. Okay. So how this course will be taught? Okay, so this course will be, so there's a very unique thing about the way they teach at IITs. Okay, so I've done my master's from IITs and I've done my BTech from a private college. So I've seen the board words. Okay, and I was always a average student, like 70%, 72, 73% throughout my schools, and even through my BTech also, it was like 74% for my BTech aggregate. Right. And when I joined IITs, I was actually a 9-pointer at IIT. So I think 99.2 or 9.26 or 9.5, I don't remember. It was a 9+, right? So how this happened, this change happened, right? How did I go from like 7-pointer to being a 9-pointer at IIT? Okay. So that is the secret of that is completely in how they teach at IIT. Okay. So at private colleges, I think of you are from, right? Nobody teaches anything, and you have a fat book, and everybody just sits on the last day to finish that book, right? Somehow. So it's the same story, right? But at IITs, it's very different. We have to only study what professor teaches in the class, and you just prepare your notes. And in the exams will be only from that thin uh, set of notes. Okay, so, Nikita, this meeting is getting recorded actually. You don't need to record it locally. But anyways, I'm allowing it. Okay, just uh, so yeah, coming back to what I was saying. So basically at IIT, you have to just maintain a small thin register of the concepts that professors teach in the class, and that's it. On the last day of on the examination day before examination, you have to just read that thin register. That's all. So exams at IITs were very easy, but the life at IITs was hell. And the reason for that are the practical assignments. Okay, so every subject you will get an assignment which is so huge, and for entire week you'll have to like sleep. You'll hardly get time to sleep, and you can't miss the assignment, because if you miss the assignments, you'll actually your grades will go down, because assignments form a much part of your grades, actual grades. Okay, so that is how why the IITs or NIITs or all the good colleges bids in India work, because it's not like the teachers are like extraordinary or the students are extraordinary. Rather, this is the more of the way they teach, right? Through the practical assignments. Uh, and those are like very hands-on, and you actually learn everything here, right? So same is the format of this class also. The classes that I'll be taking, that will be like 20 or 30% of the learning, and actual learning will happen through the practical assignments that you'll do, right? So now you understand why this concept of deposit is there, right? Because if you miss the assignments, you don't learn anything, and that's why now you also have the fear of losing your deposit. Okay, so that's how this course will be taught. Okay, so so yeah, before I talk about finally this course, let me quickly tell you about the different job profiles in IT industry. Okay, so what this course is about, let me tell you in a nutshell. So my dream with this course, or my sole motive of running this course, is to uh, definitely it's the social work, right? And when I started doing social work, I thought, what is the best kind of social work? So giving somebody money definitely doesn't help, right? He'll come back to you again the next day. But if you teach somebody to earn money, right, then you set him up for life, right? And I want to like target those people like who have completed their studies and who are not able to earn. or not find a job or start a career. So those are the common people, right? I see in my tier 2 cities. I live in Kanpur, so I see people here, my relatives, my friend circle, right, who have completed their BSc or MSc or MA or BA, and they're sitting at home, right? So those are the kind of that's the target audience of those. That's the kind of crowd I'm trying to help through this course. Okay. So the idea of this course is that within 3 months, you will be kind of equal to a computer science BTech. You will understand. Hopefully, you'll be better than that because this is like IIT style of teaching. So you'll be better than at least the private college BTechs, right? And you'll understand each of the job profiles in IT industry, right? And throughout this course, you'll do all very different kind of assignments. You'll do coding, some little bit of coding you will do. You will do a little bit of like creative stuff. You'll do a little bit of graphic designing, and you will do a little bit of maybe some management stuff as well, right? Through the assignments. So you'll learn every like the technical roles. You'll understand what it takes. You'll understand what it takes to be creative, or you'll understand what it takes to be semi-technical, right? So all these job profiles you'll understand first of all, and you'll also do all this stuff little, right? So that way you'll get a taste of everything. And the idea or the concept of this course is that by the end of 3 months, you will clearly understand ki what do you like in IT, right? Whether you are a very technical person, you are liking technical stuff more, or you are liking creative stuff more, or you're liking semi-technical or management stuff more, right? So you will be able to then maybe at end of this class, there are 15 job profiles actually that I'm trying to target through this course. So at the end of the class, you'll at least be very clear ki hi, these 3-4 job profiles are the one that I want to follow going forward. Okay, and then after that, at the end of the class, what I do is usually I do a one-to-one counseling of every student, and then I'll give him deep dive or specific paths. I'll give him more material, more courses on specific paths which he can use to further start interviewing for that particular position, right? So basically, you'll do deep dive after this, right? So, but this course is like a basic course that will set up your foundation. Okay. So some people ask me, ki, I want to be a business analyst. Why should I learn coding, right? You will understand all those questions. Ki, even business analyst, even it's a management kind of or it's a semi-technical position, but even business analyst needs to understand everything of coding because that's what they write business cases around, right? So all those things are important because even though you don't like coding or you are not a technical person, still you should know a little bit of everything, right? And what I'll be teaching you is if there is like 100 is the complete thing, I'll be only teaching you 20% of it. Okay, so don't worry. I'm not going to teach you any of the data structures or algorithms in this course. Okay, I'll just teach basic programming. At least you can write small programs. That much programming you will learn. Okay, so don't worry or don't be afraid ki, array, this will be a very technical course. Will I be able to do it or not? Okay, so all those things will not be there. Okay, it will be a very hands-on, very layman-like course, right? And that's what I'm trying to strive for. Ki I should be able to teach at that level, right? And that's where I need your help. Where you should interrupt me and ask more questions if you don't understand. Okay, so yeah, I've just seen the list of students. I think Jyoti, you are from arts background, right? So okay, people are still paying.
Yes, sir. Oh,
Okay.
sorry, Rahul.
Yeah. Sorry, I think there are people who still don't have the Zoom link. They're still paying and just getting the screenshots of payment now. The problem is they will do everything at the last moment only. So let me share the Zoom link. Just give me 1 second. Okay. So yeah, any questions till this point? Anyone? Yeah, there are 31 people. Nobody's asking any question. There's no curiosity, that means.
Good to go, Rahul.
Okay. Okay, then I'll proceed. Okay, so finally, how to get best of this course? One mistake that I've seen that the students do, I've seen in the past, is they select a specific role. Okay, and then they'll think, I want to be a programmer. Oh, pehle mahine mein they will decide, and then they'll start going in that direction. Okay, don't do that. Okay, be open till at least the end of 3 months. Ki, don't lock any particular profile in your mind. Ki, I want to do this only. Okay, try out everything, taste everything, and then at the end of the 3 months when we'll do the counseling session, then we'll decide. Okay, then we'll try to figure out. I'll see, go through your work, I'll go through your assignment, and then based on that we'll take a call. Okay, so uh, throughout the course, try to learn everything. Okay, whatever I'm teaching is very minimal. It's minimal of the minimal stuff that I'll teach you. Okay, so it's all foundational. Everything is important. Don't skip anything. Okay, so don't lock a specific role in your mind up at this point. Okay, be open. Okay, so content of this course, you all would have already seen the curriculum, but yeah, I'll quickly repeat it. So yeah, we'll go very layman style. Okay, so we'll start with parts of computer. We'll understand how computers work, similar to how okay, how cars work or how cycle works, right? We'll go to that level of basic understanding. सबको समझ में आना चाहिए कि computer कैसे चलता है. Everybody should be able to explain their parents after this class how computers work, right? Then we'll understand how operating system works, right? Why do we install operating systems? What are operating systems, how they work, right? Then we'll understand how programs work, what are programs, how they work, what is the concept of programming and all that, right? We'll also learn a programming language. We'll learn Python in this course, basic Python. And once we have learned programming, little bit of programming, then we'll go to the networking part or the internet, right? So everybody uses websites and web applications or mobile applications. So that's how we actually use computers, right? At the end of the day, nobody uses computer to just see Windows, right? Or just see Linux, right? Operating system and is there to actually help you run all these stuff, right? The actual applications. Android is there to support the mobile application that you install on your mobile, right? But without any app, your mobile is kind of useless, right? Even the phone app is the app, right? So we'll understand what is internet, how internet works, how networks work, and how website and web applications work, right? And then we'll look into also how do we develop these stuff, right? So we'll learn web programming, we'll learn little bit of web programming, we'll learn web technologies and all, right? So, and then as part of that process, we also will have to store data. So we'll also briefly look at what are databases, how databases work, right? And finally, we'll, yeah, this I already said, we'll learn how to create web apps, right? Fine. So this is all maybe technical and creative stuff. Now the management stuff, right? In the software industry, how the stuff take place, right? What are the different management rules? What is the software development process? What are the different softwares used in that process? What are different tools? That all that we'll see at through the last 2 weeks of the course. Okay, so this is how this course will work, and these, if you have identified, all these things are actually subjects in BTech computer science, right? So there is a computer architecture subject they teach in the first year, right? And the second year they teach operating systems. In the second year, probably they'll also teach programming, right? Then there will be computer networks. There will be internet technologies. There, some institutes teach that subject, internet technology, or it's part of the network, computer networks only, right? And then there's a databases subject, right? And then there's a software engineering subject, right? So in a way, I'm actually covering BTech curriculum only, but the basics part, right? And in a layman style. Okay. So this is all about this course. Now we'll talk about how to be a successful person in the IT industry. Okay. So the biggest skill, if you would have seen that earlier session also that I took for laid off folks. So same thing I explained there, right? So biggest skills in a good engineer or good IT person that are required are first of all, you should be a self-learner or quick learner. because in this industry, every year there's something new, right? Abhi chat GPT aajkal chalta hai, right? Everybody would have heard of it. So every year something new is coming up. So you have to learn. This is like I'm I'm doing my 12th year in the industry, and I still have to read stuff. I still have to learn stuff, right? So learning here doesn't stop. It's not like a government job, right? So here technologies and tools keep on changing, keep on advancing. It's a very rapid industry. So you definitely have to learn how to learn, right? So you have to learn how to be a quick learner, okay? Or you have to learn how to self-learn stuff, right? So I'll talk about that also. And other thing that you have to learn is debugging, very important skill. Java is not a skill, C is not a skill. All those languages and technologies that you learn, those are just tools, right? That those are like hammer or a screwdriver that your plumber or electrician carries, right? Those are just tools. Rather, the actual skill that you need to learn is debugging. Key is something is not working, how do I debug or triage a issue, right? So triaging or debugging is the actual skill that you'll have to develop, and that's what we'll try to do through the assignments in this course. Okay. So any questions around this? Okay. So uh, I'll first tell you the most important skill. I'll teach you the most important skill that you need to learn as a IT student is self-learning. कि सबसे पहले, how do you help yourself, right? Without taking help from anybody else. So this is the very recent thing. Last class तक ये था भी नहीं picture में, लेकिन now this is everything going on in the world. Okay, so I'll start with the demo of ChatGPT. So what is ChatGPT? ChatGPT, I don't know, बहुत पहले एक serial आता था. I'm trying to remember this guy was there, right? Villain Suman, Captain Vyom. How many of you seen Captain Vyom? Can you raise your hand? There is a raise hand button in Zoom.
A big fan.
Big fan, right? So if you remember in Captain Vyom, in some episode at some point, there was a brain, right? Which was like very powerful brain, and that brain was kept in some jar, and uh, uh, he knew everything. You guys remember that scene or that concept? Who was the big fan?
Yes, yes, Sunny.
Yeah, Sunny. So you remember that concept or not?
Yes, I do remember that, and that was the good part.
Right. So ChatGPT is the same thing. So what they have done now, let me take a minute and talk about ChatGPT because it's worth talking about. So see, in our brains, how humans think, right? How is our brain made up of? We are made up of neural network, neurons basically, right? So we have these cells called neurons, and we have like billions of neurons in our head, right? And in our brain, that's what forms our brains. And all these neurons together form a human brain, right? So let's say human brain has 1 billion neurons. Okay. So what these AI engineers or scientists have done is that they have converted this neuron into a program. Okay. So they have now created a programming version of neuron. Okay. And they have created like collection of such so they write, let's say उन्होंने एक program बनाया which is a 1 KB. Okay, a lot of you will not understand what is 1 KB. It is a unit actually 1 kilobyte basically. Okay, byte. I'll talk about all these things later in the course, but yeah, just hold on with me. Okay, so let's say that program is 1 KB in size, right? So what they have done is they have multiplied it by like 100 billion. Okay, so they have created a clustered program, which is a cluster of 1 billion neurons. Okay, so now you can assume that single program is now equal to 100 brains, human brains, right? And what they did, they fed it the complete information on the internet. Ki bhaiya ye padho and learn this. So this program actually, it's like a 800 GB sized program, which is ChatGPT, which is a AI model actually, huge model, which has been fed all the data on the internet till 2021. Okay, so it's a 800 GB size 2021 data model, and it knows everything, right? It's like that superhuman. It can tell you anything. You can ask anything. You can. I have started using it for teaching also. So a few of the notes that I'll use in today's class are actually from ChatGPT, and you can ask it anything. Any error that you see anywhere, you just put that, copy that error and paste it, and it will answer you intelligently. You can use it for anything, like uh, anything at all in the world. You can. It's a superhuman. Okay. And this is Chat GPT. This is GPT-3. Now there is GPT-4, which is much. I think GPT-3 say GPT-4 is like 10 times bigger in size, and it has a GPT-3 had data only till 2021. GPT-4 has a direct connection to the internet. Okay, so it's like insanely powerful. GPT-4 is not available to the general public. GPT-3 is available. To access GPT-3, you have to go to chat.openai.com, log in with your Gmail ID. Okay, so and you'll see something like this, right? So, so let's say ask it something just for a
Uh,
demo.
can
Hello.
I share something here?
Yes, yes. Please go ahead.
I am from Haryana Police, and our officers and we have used this Chat GPT for many manuals how to tackle with the crime in our state. Even many SOPs were created by using this Chat GPT in our state, and this Chat GPT really helped us to get the results in even for the state like Haryana. The crime we used to search here, they are giving so accurate information about that. Uh, that is really wonderful for us that even crime is included in the Chat GPT.
Right. And actually, this is also one of the reasons why you should upskill yourself, because going forward, all the menial jobs which are there. Recently, I saw a mashup where uh, somebody has used Chat GPT for like mm, answering, basically conversing with a like call center guy, customer care guy. And he has used another AI which basically converts text to voice. So he has combined those two models and created a mashup. And that mashup, using that mashup, he was able to call his insurance company and get a refund. So basically, this whole AI actually talked on his behalf, did the call in his own voice. Actually, he gave his voice sample and it replicated that voice, and he was able to get the refund. So what does that mean? That means ki all these uh, cold calling jobs will go away in next few years. Okay, so if somebody has done that experiment, he has done the proof of concept at least. So all these jobs are going to go away. So all the cold calling jobs, marketing jobs, I have to just give 500 phone numbers to ChatGPT, and I'll run 10 copies of ChatGPT, and it will simply call. And it will know it because it knows how to talk also. मतलब अच्छेदार बातें कैसे करनी है, it will know all that stuff also because it has all the knowledge in the world, right? So a lot of my LinkedIn posts, I have actually used ChatGPT to generate the content. Okay, I'm not a very good English writer, so uh, I'm not an arts person, so even I'm using it for that, right? A lot of social media influencers are using it. So this is going to change the world drastically, and it is going to happen at a very rapid pace. In the next 5 years, you'll see a lot of changes in the world and a lot of jobs actually getting lost. Even in programming, it is now going to it is making stuff like 3x faster. Like now I don't have to write program. I have to just give the pseudocode to ChatGPT and it actually is writing the complete program for me. Okay, so I've done those experiments. Whatever program probably would have taken 5 to 6 hours for me, I was able to do that in 1.5 hour with ChatGPT. So that means all the basic level programming jobs are going to go away. A message to all the lead coders in the group. Why I'm so much against lead code. Why are you wasting so much time? 500 questions, 1,000 questions you are solving on lead code. Learn problem decomposition. Learn how to do real world stuff. Learn end-to-end picture. कि software को पूरा 0 से 1 तक कैसे बनाना है. Don't just go in data structures. Like people are wasting so much time in just lead code and data structures. That's not going to help. Because now ChatGPT is able to solve all the lead code problems also. Okay. So basic programmers jobs are getting killed. 90% of the resume using my during my resume drive, I got around 200 resumes. 90% of them were those who are fired under 1 year, those are like who got fired within 6-7 months, and a lot of resumes are from Amazon or big companies also. So my assumption is it is because of ChatGPT, because all those basic coding jobs now ChatGPT can actually replace. Okay, so yeah, just be aware of all these things. Okay. Okay, coming back to where we were. So self-learning. First tool is ChatGPT. Whatever you want to do. Okay, I was to give a demo, right? So why, or let's say ask the same thing. What are different jobs in IT? So, okay. Yeah, if you don't use it for some time, it goes stale and you have to refresh the page. Right. So this is actually the AI or the big brain, super brain, which is there now in form of this model who is answering this question for you, right? So I'm going to anyways cover these different positions, so don't worry about that. Okay. So first thing, whenever you get stuck, whenever you want to learn about more depth about any concept, you just go to ChatGPT and simply ask that question. It can even understand Hindi. Okay? So if you are not, if you are weak in English, so you can just type in English also. Okay? It also it speaks any language in the world. So you can type in Gujarati or Kannada or Telugu, whatever language you want. Okay, so that's another one. Next is you should know how to use Google. Okay, so before ChatGPT just came a few months back, but before this, like Google was the go-to place for every software person. So um, so Googling tips you need to learn. Okay, I'll talk about Googling tips. Okay, I used to teach that till the last course, so I'll cover that also. So you should know how to use effectively Google. I'll teach you that, right? There are some tricks and tips around using Google effectively. I'll quickly tell you about that. Then next thing to use is Wikipedia. For okay, one thing that I recommend in my courses that you should have a notepad next to you in any form, digital notepad or a physical notepad, and you should keep on noting down the topics that you don't understand so that you can go and read about them later. Okay, because computers, like every domain, has a lot of its own jargons and terms, right? Which you might be hearing for the first time, right? So keep on noting down these terms, and at the end of the after the class, you can always go to Wikipedia and search for these terms, right? So let's say I didn't use any term till now, but let's say let's pick any term that I've talked about till now. Okay, Scrum Master. What is Scrum Master? Okay, so you go to Wiki, you type keyword Wiki on Google, and then write the term whatever you want to search, and then you will automatically see the topic Wikipedia page for that particular topic, right? So you can understand the concept of Scrum now from here. So Wikipedia is like really good for technical stuff. I don't suggest it for political things because again, the whole politics thing, this is all skewed information on Wikipedia because anybody can update it. But for the technical stuff, Wikipedia is very good. The because this is again open source, right? Anybody can edit it. So this content that you see here has been reviewed by hundreds of people all over the world, right? That's why it's very refined. So in like just reading few initial paragraphs, you'll easily learn about the concept, right? It starts with a very basic thing and then it goes in very detailed, right? So it's like Wikipedia is the best source to learn concepts after ChatGPT now, because now ChatGPT has taken the ground now. Okay, so Wikipedia is definitely important to learn concepts. Whenever you get any errors when you are solving assignments or you are doing something, so you use Stack Overflow for that. Okay, so I'll teach you how to. Stack Overflow is actually a website where you can ask questions. Okay, uh, so you don't have to go on the website. Basically, what you can do is you go to Google only. Okay, and some error that you are getting. So error in I'll just simulate some error in Linux. Okay, so some error in Lex, you will say site colon Stack Overflow. Okay, no, okay. See, Google is so fast. It saw that it's error in Lex, so it's self-existing site of Stack Overflow. So Google has this keyword site colon where you can say site colon and give the name of the website. Then it will search or give you the results only from that website. So this is how actually you will search within Stack Overflow. Okay, so whenever you get any errors messages and you're getting stuck on that, use that, use Stack Overflow. Okay. Just to give me one second, somebody else is asking for a Zoom link. Okay, so that's the concept. Another thing that you can use for debugging purpose. When I said now you have to learn debugging and triaging. So for that, Stack Overflow is good. Okay, definitely is there. Then for concepts or some installation steps or something that you are stuck, YouTube also has a lot of videos on IT stuff, right? So search YouTube also. That is like more interactive way. And a lot of times you might want to see how things look like. So Google image search is also a very good way to visualize stuff. Key, what I'm talking about, you might get some diagrams around those concepts, which might help your understanding. Okay, so use Google image search also. Finally, this is a more advanced advice. So some topic that I teach and you want to learn more about it, there's a hack actually. So reading stuff is difficult, but if you see PPTs that teachers use all over the world in their courses, in their university, those PPTs have always concise way of stuff. Okay. Uh, you can always use university slides. I'll tell you how to search for them when I teach you Googling tips. Okay. So you can search for university slides for specific topics, and those are like those are kind of a gold mine on learning concepts and details. Okay. Okay, this is there's something called Markdown. I'll talk about that later. Even these notes are in the Markdown format. So I always prepare small notes for everything, digital notes. I keep them on Dropbox so that I can access them anywhere whenever I'm going for an interview or anything. So that way, it's easy. So I'll teach you about this later down the course, how to make Markdown notes and all. Okay, and there's a 30-minute rule. When I joined my first job, my manager taught me this. Whenever you get stuck on something, always put a fight for 30 minutes by yourself. Use every tool that you have, Stack Overflow, Google, ChatGPT. Try to solve yourself and unblock yourself. But if after 30 minutes you did like honest effort and you are not able to solve the problem in 30 minutes, then get help. Okay, then ask someone, get on this WhatsApp group that we have. Okay, or don't ping me directly, ask on the group only, so that everybody gets to see your query, and others can also answer. And if I answer also, then everybody gets the benefit of that, right? So I don't prefer somebody doing a direct message DM to me. Okay, and finally use these recordings also. Okay, so this is, I'm telling you all the secrets. Nobody will tell you all these things. See how to become a master of self-learning. And this is like a life skill, not only for learning these IT things. This skill you can use for anything in Word, to learn any skill by yourself and become a master of at that. Okay. So this was for ChatGPT. So let me get it here on under ChatGPT. Okay. So yeah, I think that is one last thing is left. Before we start the course, that is the Googling tips. Okay, last thing on self-learning. So a lot of you might already know this, but few of you might not know this, since this is a very basic course. That's why I'm telling everything in detail. So in Google, you can use quotation marks to do a specific search. Okay, so let's say what I mean by specific search, let's say you get some error and you want to search for exact same error, right? So what you do is you put quotation marks and search for that text. Okay, so let's take some example. Rahul is a skilled painter. So what this will give me is the results or the web pages where the exact same ditto that sentence is there, right? If I don't put question marks, then it can search some of the words from that sentence, right? It might still give you the correct answer, but when you want to force Google to give you the exact match of the entire sentence, right, or entire error message, then you can use quotation marks. And whenever you are using or Googling for errors in this way to search for solution, always remove variable things from the error messages, because error messages might have some part of them might be variable, right? As in, it might say ki, file xyz.txt not found, right? So xyz.txt is something that it is there in your context. So you can remove xyz.txt and rest of the message you can put in quotations and search, right? That way, I'm just giving you a very basic example, but you might see very complicated error messages and you might want to unblock yourself and debug that. So use this step for that, okay, using the quotation marks. Sometimes you might want to remove few things, right? I don't want this. These things should be there, but I don't want Rahul Gandhi to appear. Some of the searches of Rahul Gandhi might start appearing. So what I'll do is I'll do minus Gandhi, right? So the search will still be on around Rahul and skilled person, these keywords, but it will definitely remove everything on Rahul Gandhi, right? That because I'm subtracting that step. So again, this minus is subtraction sign is a useful keyword in Google, right? Site colon, I already gave the demo. Similarly, you can do a or search using vertical bars. So example of this is, like I was telling you, you can search for slides from foreign universities, right? So even in IITs, like professors upload their websites online, and even all over the world, the big universities, they upload their universities. Professors actually upload their teaching slides online. So how to find those slides, right? So let's say Linux basic commands. I want to find slides for these. So usually file types for slides are PPTX or PDF, right? So when I want to do a or search, that's where I use that vertical pipe, right? It is there on the keyboard, right? So if I do this, so now if you see, I'll see the only results that I'll get is PDF files or PPTX files, right? I can remove PDF, so then I'll see PPTX also, right? And if you, okay, I'm still getting, okay, so this is a PPT file, right? So if you open this, it will actually be very useful, and it quickly teach you Linux commands, right? This is even faster than reading a tutorial online or watching a video. You just see slides. Okay, why is my PowerPoint not opening? Okay, it's taking time, I think. Right, so this is the slide that I just opened. It's still loading. Okay, anyways, we'll come back to that when it loads. Right, so if you see, you're just getting the notes, minimal notes. Okay, even though this slide is not good, but these are the ways you can quickly learn concepts in detail. These are sort of the hacks that you can use to learn concepts in detail. Okay, these are like general hacks. You can use it for anything. Wiki and search term, search in Wikipedia, I already told you, right? And then if you want to search for tutorial on anything, you can just say the term name and then the tutorial. That's how you'll get the tutorials for that topic online. Okay, so yeah, I think that was all on the general gyan, and now we'll start with the course. Okay, so the first topic that we want to cover is what are computers and how computers work. Any questions till this point before I start this topic? Okay. Okay, so just give me 1 minute. So we'll start with parts of computer. Okay. Before we go to parts of computer, let's talk about parts of our body. Okay, and compare computers with human beings. So what do you think is the most important part in our entire body? Which organ is the most important organ? Please unmute and answer.
Brain.
Brain.
Very
Obviously
good.
brain.
Exactly. Because again, go to that Captain Hume experiment. That was actually a human being that they were trying to show who is still alive, and they've just preserved the brain out of that human being, right? So they were showing some advanced, some scene from future where they were able to, humans were able to survive using by preserving just their brains, right? So, and that's very much possible, right? Maybe 100 years down the line, we might convert into some sort of cyborgs, and all this everything under the neck might get replaced by machines, but definitely it will be difficult to replace the brain, right? Definitely brain is the most important part of our body. So if I have to say, like, after brains, what is the second most important function or thing in the body? What will you guys say? What will be the answer?
Heart.
Art.
Heart is more like an engine. So I'm assuming in some mechanical word, in some advanced technology 100 years down the line, maybe heart can be replaced. Already now they are making a mechanical heart. So definitely heart is not the answer.
Spinal cord.
No, spinal cord is also not. You can also give
You can
that.
also do that.
Lungs.
Liver.
Lungs.
Yeah, liver, lungs.
Yeah, liver, lungs.
No, see, all these things are
All these things
for
are required for
survival. Okay, so I'm getting.
survival. Okay, so I'm getting.
Eyes,
Eyes. Eyes.
Eyes is a good.
Eyes is a good.
Hey, Aisha, can you mute?
Hey, Aisha, can you mute?
Okay, yeah, I was getting mute echo from Aisha's computer. Okay, so eyes is a good answer because eyes or senses is something which is the most important thing to us after the brain, right? So brain is one, and then the senses, or which we can say in a way, what are the senses? These are the input and output devices in a way, right, in our body. So we are perceiving the world, which is sort of an input signal for us, right? We are smelling, which is again like an input signal for us. We are touching and feeling things, so that is the input signal for our brain, right? So all these input output devices are important to us, right? People say ki, हाँ ठीक है, you will replace the body, spinal cord, heart, liver, lung, everything by robots, but will robots feel stuff, right? That's the important question comes. If I get a robotic body, will I be able to still touch and feel stuff? Touch will be there or not, right? So those are the important things or meaningful things to us, right? So if I have to say, most important things which are important to us are the brain, which is the processing unit in our body, and the senses, right? So same thing is there in computers also. If I now go to the computer analogy, so computer is sort of a made in our own image only. So brain, if I have to say what is the analogy or what is the thing that replaces brain in computers, it is the processing unit, which is a processor, right? And the storage unit. The storage unit, again, it can be like short-term memory or the long-term memory. Short-term memory is something that maybe when you are sleeping, then that memory is not active, right? Which is like even in humans, we have the concept of short-term and long-term, right? So when you are sleeping, if I take the phase when you are not dreaming, at least your brain or short-term memory or the present moment that you are experiencing, you don't experience, right? So that short-term memory is kind of turned off, right? When you are sort of in hibernate mode or shutdown mode, right? Let's call it hibernate mode, not shutdown mode. And the long-term memory that we have is again in the brain, right? So similarly, computers also have a short-term memory, which is the RAM. So once you turn off your computer, RAM gets flushed, right? Nothing gets stored in the RAM. So this is RAM is only active when the computer is turned on, right? So this is the short-term memory for the computer. And similarly, the permanent memory or the permanent state which is stored in the computers is in the hard disk. Okay, so all the art folks, commerce folks on the class, anything that you don't understand till now? Any questions?
No, sir.
No, matlab kya ki you understand everything or you don't understand anything?
Yeah, I understand.
Good. Okay, so so that's the concept of the parts that are replacing the brain in a computer. And similarly, for the senses, we have input and output devices in computers, right? So like we have eyes, similarly, computers have cameras, right? So camera is a input device for a computer, right? So I can write camera also here. And for visualizing or showing you the stuff, what is going on, you have an output device, right? So display is, camera is a input device, display is the output device. Keyboard is the input device or output device? Jyoti Singh.
Input device.
Very good. Yeah, I'm sorry. I've just identified a couple of folks who are from arts background, so I'll be taking their names. Okay. So input again, mouse is like keyboard is a input device, right? And printer
Mouse
is
is
output device, right? So that's what computers do, right? So if you think what computers do, they are doing some processing for us, right? That's why they are useful. We give them some work and they do that work, or basically we give them some input and they convert that input into output, desired output for us, right? That's why they are useful. So example of this, can you guys give some example of useful works that you do using computers? Quickly. But ChatGPT is also an example, right? You are giving the input, and then as an output, you are getting all this useful information. Right. So, Intisad is saying that take a intro to the IT masterclass from Zoom. Yeah. So using Zoom, we are all able to connect, right? So, input, if I have to say in input output terms, it's more of a kind of allowing us to collaborate together, right? It's I can't define in an input output way, but input output is actually I'm sharing my screen and you all are able to see it all over the world, right? So I'm giving some input and then output is going on like 31 terminals right now, right? 31 mobile devices, or so that's the input output going on here, right? My screen and voice is getting shared all over the world, right? So that's how Zoom in a way is working. Yeah, somebody said client server. I will not use that term right now because uh, that we'll talk about technical terms later. Okay. Okay, so now you understand some parts of computer, right? So now you understand the term processor, RAM, storage, input, output, right? Very good. So now let's talk about how computer works. Okay, so this was just parts of computer. So before going to how computers work, let's take some analogies from real life. Okay, so computer is like a cook following a recipe. Okay, so what I mean by this? So what we do, what we ourselves don't write programs, but this ChatGPT is also a kind of a complex program. Who somebody or a group of people or a research group, which is research group was OpenAI, their software engineers would have created this ChatGPT, right? ChatGPT program. So you can think program is like a recipe, right? And cook is basically computer. So the way you give a recipe to somebody who's cooking, he will just follow this recipe step by step and execute that recipe, right? And finally, the raw materials that you gave will be the input, and finally the prepared dish will be the output, right? So similar kind of stuff computer is also doing, right? So you give it a recipe in form of a program, which you might not be given, but somebody is giving, has written the program, like the Zoom program, somebody would have written. And now we are all enjoying that dish, right? It's a Zoom dish. We are using the Zoom, right, for our use case, right? So do you guys understand this analogy in the first place? How computers or programs are like a cooking a recipe. Any questions on this? Okay. So so this is one analogy, right? To understand like what computers do. Computers are basically like a cook, right? They follow a program or recipe or program, and basically cook here is a computer, or you can also say processor. So I'll talk, let's call it computer only for now. Okay. So now, so basically in computer, like actual processing happens within the processor only, right? And storage is just for like storing the data that you are giving to the program, right? That let's say you want to add two numbers, 1 and 2, and you write a program for very small program for adding those two numbers, right? So those two numbers, so the program, so those two numbers have to be stored somewhere, right? Which you give as inputs. Let's say you want to add 100 numbers. So I'm just talking about a larger program, right? So which basically processes all these 100 or thousands of addition problems and then generates a result, right? So all that input and that program needs to be stored somewhere before the processor can process it, right? So all that information has to be stored somewhere. Permanently, if it has to be stored, it will stay in the ROM memory. ROM full form is read ROM.
Read only memory.
Yeah, read only memory, and RAM is random access.
Random access memory.
Okay, so
Random access memory.
Terms somebody coined. Don't I don't know why they coined it that way, but think of that whenever I say permanent storage, you think of hard disk, right? And whenever I say short-term memory or temporary memory, then think of RAM, right? Everybody knows about hard disk and RAM, right? So think it in that way. Okay, don't get confused by these terms. Anyways, so basically, if you think about the same thing, so we need storage for storing the data, and we need okay, so and you need processing something, some processor who processes all these the programs and the data that you're passing, right, to convert input to output, right? So that all stuff goes within the processor. Okay, so finally, let's see in more detail what is processor, and now let's deep dive. Let's take a lens and like go inside a processor. Let's see what goes inside a computer in more detail. Okay, so again, one more analogy I'll give you. Okay, you guys would have seen a car factory assembly line, right? Let me open a Google image search for this. So something like this, right? Oh, sorry, earlier image was better. तो यहाँ पे क्या होता है, every unit or every station is working on some part of the car, right? And every station does the same work, right? Let's say this robot will just put front tire, right? This robot might be putting just the back tire, right? So every car there's a set of cars which are coming in for getting processed, and every station or every unit is doing some same work, repeated work, one by one, right? Similar, you can think in McDonald's also, right? Or some restaurant also, you have workstation. Like when you order a burger, like some guy might just be preparing tikki of the burger, right? Some guy might just be putting butter on the buns, right? Some station guy might be just wrapping up stuff together in the wrapper, right? So again, in that analogy, restaurant analogy, these robots are getting replaced by human workers. Each of the worker which is doing some specific function. Okay, so similarly, within a processor, there's an assembly line like this. Okay, and what is coming is actually a line or a small operation to be done. Okay, and there are parts of the processor or specific units in the processor which do specific works on that part of the instruction that is coming in. Okay, I will don't worry if you don't understand this, we'll go in more detail into it. Okay, so before I go into that, let me tell you about the parts of the computer first, or parts of the processor first. Okay, which are basically parts of this assembly line which runs within a processor. Okay, we'll talk about this kernel programming later. Okay, so just focus on this thing. Let me stop. Yeah, this is slightly complicated. So if you don't understand anything, feel free to pause me, repeat, ask for a repeat. Okay. Uh, so the first part in a computer is the control unit. So what this guy does this is the guy who basically loads stuff on the assembly line. Okay. So what happens is within a computer, okay, maybe even before going to the parts of the computer, let's talk about little bit of electronics. Okay. Let's talk about logic gates and instruction sets. Okay, so this is a slightly mathematical concept. There are few small mathematical concepts we'll talk about. So don't get afraid by them, all those art students and commerce students. Okay, so we just go to Wikipedia and learn about logic gates. Okay, so logic gates are basically electronic circuits. This is not a computer concept. This is a electronics concept. Okay, even I'm not expert at all these things, but there are transistors within which you can implement these operations like AND operation. Okay, so language of computers is just basic 0 and 1. Okay, what 0 is basically a signal is there, signal is not there, and 1 is basically a signal is there. Okay, so if like within a fraction of second, whether you are checking whether that electricity is running on that wire, then that means a 1 signal, and if electricity is not running in that wire, then it's a 0 signal. Okay, so so these electronic chips, transistors basically implement these operations at the very low level, which are called logic gate operations. Okay, so what it means, if I say not operation, it means ki it will invert. If the value is 0, then if not chip is there, it will basically give a opposite output, right? So if electricity is not there, it will give output as 1. If electricity is there, then it will give output as 0, right? Similarly, there are more logical operations that you can implement, right? And or NAND, NOR, LOR. So these are, you would have, I think a lot of you would have studied these in your school also, right? During the computers course, if you would have taken. So you probably remember these logic gates from there. Okay, if you have not studied it, just go to Wikipedia and read the article on logic gate. Okay, so what happens within actual processors that you have electronic component called transistors, and you have like billions of transistors in like a very high-end processors. You will have billions of processors, if not billions, maybe millions. But let's think of a very simple processor which has like hundreds of transistors only, right? So the first thing which one compute unit is there, which is made up of just the transistor, which is called the ALU, or arithmetic logical unit. So this is the one that actually uses this logic gate concepts and is able to do some basic arithmetic operations like subtraction, multiplication, divide, bitwise operations, comparison operations, and all that, right? So there are some basic operations that this processing unit can do. And apart from that, there are some few more operations like reading some data from memory, which is called a load operation, or copying back some calculated result back into the memory, right? And like jumping from one memory location to another. So some memory access program logical operations are there, right? So like this, there are some basic 10, 20 so every processor has a different instruction set, but some basic operations every processor has got it implemented at the electronics level, right? Those are called the instruction sets of the processor, right? And every processor comes with a manual, like your refrigerator or a washing machine comes with a manual, right? So when you buy a processor, you'll also get a booklet with it, which basically explains this instruction set. Okay, so we as a user are not concerned with all these things. Rather, the people who write operating system and all, they need to go into all these concepts. What is the instruction set and all. You'll understand it later in the course, what is all that and how that is used. Okay, so but just for now, capture this concept each processor has few specific operations or instructions available at the electronics level, right? And it can do those things, right? So first of all, now you understand the processor is capable of doing some arithmetics, doing some loading from reading from memory, right? So that is the part of the ALU, which is one part of the processor. Another part is control unit, which is basically just what it does is it reads programs or instructions from the memory and it passes those programs to the CPU for execution. So control unit is responsible for managing the flow of data and instructions between processor and other computer components, right? And the control unit fetches instructions from memory, decodes them, and sends them to ALU and registers for execution. Okay, so again, storage, like I said, you know about hard disk. So actual program is on the hard disk. Okay, so once you have to read that program or execute that program, you have to first read it from the hard disk and bring it into the memory of the computer, right? The current or present memory of the computer, which is the RAM, right? And then from the RAM, you need to bring that data inside the processor, right? So inside processor also, you need some way to store data, right? Some storage units you need within the processor also. Okay, so you have something called registers. Okay, so these are very small, very high speed memory locations located within the processor where you load the data. Okay, so let's take one example. Okay, let's say Windows ka jo program hai, that is like a 1 lakh lines length of program. Okay, so basically it's a very big program, right? Windows is a very complex software, so let's assume that usme 1 lakh lines of codes hai, or 1 lakh instructions hai for running the operating system. So when you power in your computer for the first time, what will happen? See, when you shut down your computer, everything, the entire Windows is on your C drive, right? Or some drive in your hard disk, right? And it will take some time to load that program into the RAM and to send those programs into the processor or CPU for execution, right? So that's the reason when you load your computer, it takes some time to load, right? 1 or 2 minutes it will take. So if it's like 100 MB program or 10 MB program, it will take some time for that program to move from hard disk to RAM, and then from RAM to compute to within the CPU. Okay. Acha, RAM or CPU ke beech mein bhi there is one more memory which is called cache memory. Agar if you have bought computer, you would have, if you remember, L2 cache, L1 cache, or in the processor, it is actually within the processor only. But this is like a bigger memory, but registers are like very low, very small units, which are actually loaded on where the data is loaded only when it is getting executed, right? So this is like very fast. But cache is something where the data is it's like a holding area, right? From the RAM, some data comes to the cache, and then from the cache, it comes into the registers for execution. Okay, so I'll talk about the clock later. So now you might be getting the picture, like right? So how operating system or how the programs work, right? When you start your computer, when you switch on your computer for the first time, all this OS program will start getting loaded into the memory. From hard disk, it will go into the RAM. From RAM, it will go to the cache. From cache, one by one, each of these 1 lakh instructions, one by one, they'll start executing in order, right? So first instruction will go into this assembly line, right? Whatever you saw, right? So these cars are actually now instructions. Whatever 1 lakh instructions you saw for the operating system program, let's say this is the instruction number 1 or the first line of that program, second line of that program, third line of that program. Okay, so now these instructions are getting sent to the CPU for execution, right? And the way it gets into goes into CPU is basically the data is set in the registers, and then the ALU actually works on those registers and loads back data in some result register, which is called accumulator actually. So basically, it will read input, it will take input from the register, do its thing, which is basically implemented in the electronics or transistors on the chip, and then it will write back to some register, right? And then the control unit is actually, you can think of something which is basically putting cars on this line and taking out cars on this line. So that is the job of the control unit, right? It is putting instructions on this CPU bus. So this is actually, this line is called bus in computer language, right? This is the CPU data bus, right? So control unit puts data on the data bus, ALU executes it, and it puts it actually on the registers, and then ALU executes the operation, puts that back on some output register, and then control unit will take away that process data, right? So that's how programs work, right? Together. So all this is happening at a lightning speed within the computer. So abhi you would have heard कि मेरे पास 3 gigahertz का processor है, right? मेरे पास i3 है, i5 है, 3 gigahertz. What does that mean? Okay, so that's when the concept of clock comes. 3 gigahertz or 4 gigahertz or whatever hertz you say, that is the clock speed of your processor. Okay, so clock is basically a timing device which synchronizes or measures the speed of your processor. Okay, so what is 1 gigahertz? Let's convert that into a number. Okay, so 1 GHz to number. Okay, so 1 gigahertz is equal to 1 with 9 zeros, so which is 10 to the power of 9, or this many operations. So agar you have a 3 gigahertz processor, that means you have 3 into 10 to the power of 9, or 3 with 9 zeros operations happening or getting executed in the CPU within 1 second. Okay, so now you can imagine what is going on within a computer, right? Within 1 second, it's like 3 I don't know what is this, billion, million, this is okay, this much is 1 billion, so this is like 3,000 million cars are passing through the assembly line in 1 second. Okay, that's one processor. And now you have multi-processors also, right? So you have multiple cores. That means you have 8 into 3,000 million operations getting executed in 1 second. Okay, so you can imagine the scale of how fast our computers are nowadays, right? And you have even within mobiles, you have octa-core processors with 2 gigahertz processors, right? So within like your pocket, you have so much powerful computers nowadays, right? And all that power is coming from the number of transistors you are packing at the microscopic level within the chip. Okay, so that is where the chip fabrication and all those technologies come in. Nowadays they are packing more and more transistor or more and more of these ALU units within the processor chip, right? So it's like mind-boggling, right? How this whole thing is working. Any questions till this point? Anything that you guys did not understand? मैं अच्छा पढ़ा रहा हूँ क्या? मैं सब समझ में आ रहा है? ओके,
लॉजिक गेट्स नहीं समझ में आया मुझे।
हाँ ज्योति, so logic gates, like I said, this is a basic operation that computers implement. Okay, so don't get worried by logic gates. You can think of plus, minus, divide, and all those things. Okay, just read this Wikipedia article, you'll understand. This is something that we even in schools also they teach. So it's a basic concept only. Okay, so what it means is कि बाइनरी अगर 2 वेरिएबल्स आ रहे हैं या 2 अलग अलग बाइनरी इनपुट्स आ रहे हैं, तो हाउ डू यू प्रोसेस दोस इनपुट्स? सो देयर इज अ एंड ऑपरेशन, ठीक है, देयर इज अ और ऑपरेशन, देयर इज अ नॉट ऑपरेशन, और देयर इज अ नैंड ऑपरेशन. ओके, सो एंड मतलब आई विल जस्ट एक्सप्लेन वन एग्जांपल फॉर योर सेक कि and basically means ki either of the 2 values, if both are true, then it will be true, or either of the one is true. Okay, that is the and of sorry, I'm telling you what or. And is basically both will be true, only then the output will be true. Okay, so if both are 1, then the output will be 1, otherwise it will always be 0. And or is ki either of the 2 is true, so output will be true, right? So this is some logical operation. And on top of these logic gates, you can actually implement arithmetical operations like plus, minus, and all. Okay, so using a combination of these gates, you can actually implement all those kind of stuff also. Okay, so don't get boggled by all these things. You can just think processor has some capabilities at the minor level, right? It understands some 10-20 instructions which it implements in the electronics that it has, right, in the transistors directly. And then whatever stuff you see, whatever operating system or whatever this notepad program I'm using, all those programs are actually at the very base level getting converted into those set of those operations only. Okay, so somehow the way I'm like moving this, whenever I'm like moving mouse or on my trackpad, actually this cursor is moving, right? So this is also a mouse program running in the computer, right? And that program at the very underlying level, at the CPU level, it is getting converted into these 20-30 operations that the processor is providing in its instruction set. Okay, so how all that happens, you don't need to worry about that, how this complex program gets converted into all these very basic instructions. I'll talk about that later in the course, but don't worry about that right now. Okay.
Okay, thank you.
Yes. Yeah, just 1 second. My computer got stuck actually. I think it's got heated up. Okay. Fine. Now it's okay. So, any other questions? Anyone? Anything that you guys did not understand?
When we say my computer is i7, does it mean the clock speed is 7 gigahertz?
No. Every processor has a clock speed, and i7 and i3 is more of a architecture thing. Okay, so I'll have to actually check that out. That's a good question actually, because you can have a 3 gigahertz i3 also, and you can have a 3 gigahertz i7 also, but yeah, definitely, i7 will be more powerful, right? So definitely the clock speed is same, but I don't want to give you a wrong answer. So let's ask our friend here, ChatGPT. Okay. If two processor question is ki i7 and i5 have same speed, but let's take i3. Why is i7 more fast? Very basic play, man. Okay, so if clock speed is same, it doesn't mean they have the same same performance. i7 is typically more powerful due to higher number of cores and threads. Okay, so it's more powerful because it has more turbo boost frequency, which means ki even though its base clock is 3 gigahertz, it can turbo boost to higher clock rates, right? So in some situations, it can maybe go to 5 gigahertz or 4 gigahertz also, right? So there's a concept of turbo boost in the processor. And then the cache size is larger. I'll talk about this, what is the role of the cache later in the course. You'll understand why larger cache is better. And then it might have more number of threads and more number of cores, right? So obviously you understand that if the core number of cores are more, then it gets multiplied. It's a multiplier, right, to your speed in a way, right? So okay, so you see now that's how you use ChatGPT. We immediately got the answer, right? Okay, so any other question? Okay, ChatGPT gives correct answers every time. Yeah, 90% of the time it gives correct answers. Sometimes it makes up stuff, but for these kind of questions, right, theoretical questions, you will get correct answers because for this there has been a lot of data that it has gone through, right? All these articles, like there are so many articles all over the internet, right? But if you ask very specific things, right, like for a very specific version of a very specific software, if I ask some question, then it might not give correct answer. It might sometimes make things up based on understanding of which might not be correct. Okay, so that kind of things, it might give incorrect answer, but still I have found it useful 95% of the time. Okay, so be aware of that. Sometimes stuff can be wrong, but till that point you are asking about general concept, it will never give a wrong answer. Okay, so I think I already covered this, but yeah, this is more of a formal definition of how processor works, right? So within processor, actually, in this assembly line, basically, these four operations are happening all the time at that very high speed, which is called the clock speed, right? So what is happening whenever you can think of when I say the clock speed is 3 gigahertz or 1 gigahertz, these many that 1 second gets divided into these many ticks or these many smaller time periods, which I'm calling ticks, right? And in each tick or of that clock, tick is same tick that you see in the clock, right? So in each tick of that clock, these four operations happen. Okay, so what are those operations? First is the fetch operation. Basically, I've written processor everywhere, but now you know in more detail, right? Because I've explained. So I'm saying the processor fetches the next instruction from memory, but actually this is the control unit within the processor, which fetches the next instruction from the memory and puts it on the data bus or within the registers or cache of the processor. It will actually put it in the registers. So the pipeline is like this, right? So program is getting read from hard disk, right? And from hard disk, it is going into RAM. Then from RAM, it is reaching the cache, which is the holding area within the larger hold. You can think of a waiting hall within the processor. And then the actual registers are the one जिसका नंबर आ गया है, जिस इंस्ट्रक्शन का नंबर आ गया तो उसका डेटा रजिस्टर में लोड हो जाएगा. बाकी all instructions will be in the waiting area within the processor, which is the waiting hall within the processor, which is the cache, right? And you can RAM and hard disk are like this is the universe, you can say. If this is the waiting hall, this is the universe, and maybe this is the city. RAM is the city, maybe, or the area, right? And this is maybe the office where the work is going on. Okay, so think you are within city in some RTO office or something, right? So this is the queue in the RTO office. This is the actual office. This is the maybe the area where the RTO office is, and this is the entire city. Okay, so that's kind of the hierarchy of storage. That is the storage hierarchy within the processor. Okay, so let me give a heading to it. Right. So coming back to this, there are 4 operations happening at every clock tick. So first is fetch, which is basically control unit putting that data into the registers. Like you can think of control unit like being the peon or chaparazzi in the office, right? It's saying, yeah, to a number, go inside. Instruction number 1, your number has come, go inside the ALU office, right? So that instruction goes in the ALU. The processor decodes. This is basically the office where the decoding and execution takes place. So processor does 2 things within a clock tick. It decodes that information and it executes that information. So what I mean by decoding is that it decodes the instruction. It determines कि इसके instruction set में 20 operations हैं, तो कौन सा operation execute करना है, and उस operation को execute करने के लिए what data is involved. So where is that data in what registers? It's not like there is just one register. There will be like 20-30 registers. So it will see कि किस number register से इसको data निकालना है, and then it will basically decode that, and then it will do the operation, which is in the electronics of that chip, in the transistors of that chip, right? So that is the decode and execute cycle. Both these things happen in one tick within the clock, within the processor, right? So this is like, now the car is loaded, instruction is loaded on the assembly line. This is one step of assembly line. This is the other step of the assembly line, right? And then finally, the result will be written in another register or output register within the CPU, and then control unit will take out the result, and then it will load the other instruction, right? So that's the store operation. जहाँ पे the result will be written to the output, okay, and then basically the next data will be taken. Okay, so Sunny is asking, please use example for fetch, decode, execute cycle, right? So I gave you example, right? You think about you're going for your DL renewal within an RTO office, right? So till here you were in the line, right? Now you got your chance to get inside the RTO office. So when the peon, which is the control unit, sends you inside the office, you are basically going through the fetch phase, right? You are going inside the office or the ALU or the execution unit of the CPU, right? And or you're basically getting on the assembly line. Decode and execute, you can think these are the 2 stations in the assembly line. In the decode cycle, basically whatever data is pulled out for processing your DL application, and then in the execute cycle, maybe somebody is putting stamp and printing out your new DL, right? So that's the execute cycle, right? And then store cycles where you're saying, yeah, this is exit gate, go out from here. Right? So, and the same time that the peon will say, you go out, next guy come in. So, right. So that's the next fetch cycle. Better. Okay. So that's at a very microscopic level, like a very detailed level, what is going inside within a computer. Okay. So I hope you have got it at that level that you can teach your parents also now. Any other questions, anyone? Okay, so actually this class is a long class. I was seeing the last class recording also. So that was a 3-hour class. So I think we'll get extended. So I'll not extend it beyond 12. Maybe we'll have a 1-hour class tomorrow or sometime later this week, as you guys suggest at the end of the. Okay. So we'll see what we'll do if it's getting extended. Anyways, this is the storage hierarchy. So as I already said, that multi-core processors have multiple cores or threads or worker. Okay, don't get confused by what is worker, what is thread. Think of that's the same thing. Like you saw one assembly line, you might have you might have 8 parallel assembly lines now, right? Within a factory, you actually in a car factory, you might have multiple assembly lines, right? So similarly, same kind of stations, processing stations, you might have replicas of that within the factory, right? You might have parallel 8 assembly lines going on. Same thing is like you have a 8-core processor, right? Or processor there is a term called multi-threading, hyper-threading, right? So that is just a gimmick actually. So what they say is key software level pay, they have now implemented assembly lines. So basically, even though there is actually one core only, but they have done some software optimization wherein they have like two parallel assembly lines or soft simulated version of the assembly line going on. Okay, so let's not go into all those concepts, you'll get confused. So you can think of a thread worker core is everything is same. It's like having parallel processing units within a processor. Okay, so I think this I already told you about. Okay, this is the storage hierarchy. The same thing is there. So if you compare the size of these hierarchies, so a hard disk is the slowest storage unit in a computer, right? So hard disk, you can have large hard disk, 1 TB hard disk, but hard disks are very slow as compared to the registers in the CPU, right? Because registers in the CPU have the same speed as your processor, right? So basically, you are doing the fetch and load, decode cycles, right, at the CPU speed, which is within 1 second. You are doing these many operations on these storage units called register or accumulators in the CPU. Okay, accumulator is also a register only. This is basically output registers are called accumulators. Okay, so registers or accumulators are the fastest storage unit in a computer, right? They are at the same speed as your processor, which is like lightning speed, right? You already saw that. अब क्या होता है L1 cache, which you would have seen when you buy processors, right? Now, when next time you're buying a computer, look closely at the specifications of the processor. You'll see these specifications will be mentioned. L1 cache 1 MB, L2 cache 4 MB, like this, right? So when hard disk can be like 1 TB, why are L1 cache so small? Because they are very high speed caches. Like hard disk may when you can maybe read data at let's say typical rate you would have seen when you are copying from your one hard disk to another hard disk. Usually you are copying at like 100 Mbps, right? But when you talk about L1, L2 cache, the speed will be very high. It will be like 10 Gbps. Okay, I'm not even talking about registers. Registers will be like way higher speed, right? So L1 cache is like yeah, registers is different. Resistors are very different thing. Resistors are electronics thing, right? Which resist electricity. Those are totally different concept. Don't get confused with registers and resistors. Okay, so and yeah, one request to everyone, like whenever you are asking a question on chat, don't do a direct message to me, send it to everyone so that everybody sees your question. Okay. Anyway, so similarly, L2 cache will be somewhat small, slower, but larger in size. And similarly, RAM, it's like more, these ones are in MB, so RAMs are in GBs. So RAMs will be still more faster. Okay, maybe I'm using the wrong RAM. These might be like 100 Gbps, this one might be like 10 Gbps. I'm just using random numbers. But what I'm trying to show is the RAM, all these things are faster, right? This is the speed comparison basically. So registers are fastest, L1 cache is slower than register but faster than L2, and similarly L2 is faster than RAM but slower than RAM, and similarly hardest are the slowest one. And then the storage is opposite. The hardest will be, even though they are slow, but they can store more, right? Similarly, RAMs are, even though they are fast, but they can not be, you cannot have 1 TB RAM, right? Because they are costly in turn, right? So this is called the storage hierarchy or memory hierarchy in computer science. Okay. Okay. So any questions till this point? Anything you did not understand?
Yeah, just one question. What does cache do exactly?
So cache, like I said, na, it's a storage area within the processor, right? So if I took that RTO office example, RTO office, you can't, the entire queue cannot go inside the office where the RTO officer is sitting, right? It will be a very small office, right? You'll have some queue, some waiting area, waiting hall. When you go to Tirupati, you have so many waiting halls, right? Not everybody can go in front of the DT at the same time, right? You have, so these, you are within the temple, but you are within the waiting hall, right? So you are within the processor. You have entered the processor area, but this is the memory inside processor, but it's a waiting hall for the instructions. Okay. So only those instructions who are getting executed will be within in the registers, whereas the other instructions which have reached processor for getting executed next, they will be waiting in the cache. Okay, there's another reason, another function of cache. I'll talk about that later, but I'll not talk about that now. Others will get confused. Okay, does the speed and size correlate, or these are independent factors? Actually, it is the cost thing, right? So whatever is fast is usually costly. That's why if it is costly, that's why you use less of it, right? So the faster the memory is, the you have this common sense, right? If something is fast, that means it is more advanced, right? The electronics is more advanced around it, right? And that's the reason it will be costly, right? So that's why the more you have this memory hierarchy, right? Within a computer, that faster memories you have less or smaller in size, but they are costly and they are like closer to the processor, right? So this is the pipeline, data pipeline is the same, right? This is the whole of the pipeline, right? It starts from hard disk and it goes from RAM, L2 cache, L1 cache, and then it reaches computer. But it's the cost and speed balance that the computers maintain, right? And sometimes you would have seen ki my computer is slow, my processor is good, so that balance has to be there. Somebody says ki bhai RAM increase kar lo computer mein, it will start working fast, and you actually go and upgrade your RAM on your laptop and it starts working better, right? So so that's the concept. Got it? I'll talk about this. What is difference between SSD and hard disk? So SSD is now an electronic version of hard disk. Okay, so actually, if you see original hard disks were made of magnetic tape. If you remember those audio tapes we had, right? Hard disk internals. So even the bigger hard disk that you see, 1 TB, 2 TB, those are made up of these rotating magnetic disks. Okay, so it's the same technology that we have been seeing from our childhood, right? Magnetic tape technology. So now there's a new technology called SSD, which is in which you don't have these magnetic tapes. Rather, you have just some chips like this, right? Which is more like your pen drive, flash technology, right? So so now as we are progressing, electronics is getting like more advanced and things are getting cheaper. So earlier we were not able to afford or create SSDs of like so much memory to so now, but it is possible, right? So previously, if you remember some years back, like you were using 4 GB pen drives, right? Now you have 64, 128 GB pen drives also. So that is all that advancement that's going on in the chip technology or the hardware industry, right? So now earlier So advantage of using these kind of hard disk, the chip SSD or the chip level or NVMe. So even in SSD there are categories, like faster ones are called NVMe. So NVMe or SSD hard disks are something. So earlier hard disk, if it used to fall, it used to crash, right? Because all these rotating hands or what do you call it? Rotating dials used to crash on this or scratch your discs, right? Magnetic disc. So इसीलिए बोलते थे कि whenever your hard disk will fall, it will go bad, and it used to happen, right? But these ones can actually fall and take a hit, right? Because there's no physical element to it, no rotating or no mechanical element to it, right? So these are better in that way. Okay. Just need one little bit. Okay, so just one reading assignment. Just read about this. This is a very good definition of processor. I like that. So just read about it. Okay. So now let's talk about very little more mathematics. Okay. So units of computers. Okay. So you would have all heard of these things because now everybody uses internet. Everybody has broadband. And you all use speeds in mobiles also, but yeah, I'm just repeating that. So okay, so basically in memory, 1 0 or 1 signal that is saved is called a bit. Okay, but you don't actually save in bits. You usually save stuff in bytes, which is basically 8 bits saved together. Okay, like 8, you basically stick together 8 values, 0 or 1 values. I'm just giving some random combination of the 0 and 1. And that combination of 8 values together is called a byte. Okay. And then you can have hundreds of these, or basically you can repeat, you can think of these, you can give this some storage location, some name. You can say, let's say this is a house number 1. Okay, so house, let's say house number 1. Okay, so or address number 1 in the memory, right? Similarly, next to it, the next 8 bytes will be memory. Okay, instead of house number, maybe I'm using term memory location 1. Okay, and then the next one will be called memory location 2. Okay, right, and so on. So if you stick together 100 memory locations or 100 bytes together, that together form a kilobyte of your memory. It can be now this 100 MB, or sorry, 1 KB can be in the RAM or hard disk or cache or L1 cache, L2 cache, anywhere, right? So because this is now a unit of data, right? It's a collection of 100 words. So basically byte is called a word because it is a combination of characters, right? Characters in computers language is bit, right? One, like in English we have words, right? We have characters, like we stick together 5 characters that form a word, right? Similarly, in computers word, if you stick together bytes together, they bits together, they form a word called byte, right? So then you stick together bytes together, you get kilobytes, right? So 1024 bytes together form a memory of 1 kilobyte, right? And similarly, you would have seen this thing also, this gimmick that all these internet companies, broadband companies do. They use a small b or a big B. Okay, they make fools of us, right? They'll say we have 100 Mbps speed, but what they'll do? They'll actually put B in a small. Okay, and when you start downloading a movie, what you are seeing is the actual speed you are getting only 12 Mbps, right? So what happened? They are using this small b, right? So they are fooling you. They are actually using bit there. So they are saying 100 megabits per second, not 100 megabytes per second. And when you so what the actual speed when you download the movie, you see is actually 100 divided by 8, which is M12 MB capital B PS, right? So that's how all these companies fool us. Now you know. Right. So letters, characters are bits, correct, and words are bytes. Yes, correct. Okay. And you stick together words, so you can say a sentence is a KB, MB, or paragraph is MB, or a bigger book is a GB, or maybe a library is a TB, that way, right? So these are actually in memory. You don't have concept of like spaces. Like in when we write sentences, we have a space, right? But space is also a character, right? So in memory computer, everything sticks together, right? In memory, locations are all continuous locations in the computer memory, right? So you don't have concept of space in computers, right? So that's why all these memory locations are continuous or contiguous memory locations, and all these words or bytes stick together and form KBs or MBs or GBs, right? And everything in computer terms is in the multiple of 1024, because that is a multiple of 2. Okay, I'll talk about all the mathematical concept later, but you can so basically you remember this factor. 1024 bytes together form a KB. 1024 into 1024 forms a MB, and 1024 into 1024 into 1024, basically 1024 to the power of 3 forms a GB. Similarly, this to the power of 4 forms a TB, and so on, right? Terabyte, petabyte, so on. Okay. Sometimes, again, another hack or another fooling all these hardest companies do, they actually use the factor of 1000 in their marketing. So if you're buying 1000, basically 1024 GB hard disk, which is 1 TB, you'll when you load it up, you'll see कि अरे तो 900 GB के around ही दिखा रहा है. That's because they use that conversion factor of 1000. Anyways, okay. Any questions till this point? All the art students, commerce students, you understand this concept? Good. So yeah, if you understand this, just one last mathematical concept. No mathematics after this in the entire course. Okay. This is also a very simple concept. Let's talk about R mathematics that we study. So R mathematics, or the number system that we follow, is called decimal number system, right? So what is the base of this number? Can somebody tell? Anyone? Chat.
Base 10.
Base 10. Very good. Right. So what is this concept of base 10? Base 10, since the base is 10, that's why you have 10 unique symbols in this language of number system that we follow. What are those 10 symbols? 0 to 9, right? Similarly, computers have a system called binary, which is base 2, right? So how many symbols will binary have? Only 2. That's why you have only 0 or 1, right? Base 10, you have 0, 1, and dot till 9, right? And then similarly, you can have octa, which I'll not talk about. This is an old system which very old computers used to follow. So we'll skip octa. We'll go to hexadecimal system, which is base 16. So computers nowadays follow hexadecimal. So when you use softwares like Photoshop and all, right, when you have to specify color, you will actually specify in hexadecimal. Color codes you might even in some like mobile apps also you might be seeing in hexadecimal. Okay. So now if you see all these color values that you see, those are base 16. If it is base 16, that means you need 16 characters, right? But our characters get finished after 9. Okay. So what they do is 0 to 9, so they'll use the 10 characters that we have. Then 11th character will be called A, 12th character will be called B. So 11, 12, 13, 14, 15, 16, which is A, B, C, D, E, F. So A to F also they'll use, right? So, so this is the actual number system that is used within the computers, hexadecimal. Okay. So again, if you are storing one character of hexadecimal, which means it is a value out of 16 values, right? 16 possible values. So at some point later in the course, we'll see how to convert stuff. We'll need to convert stuff from binary to hexadecimal and all. Maybe during some later programming or during some graphic design or Photoshop when you're learning. So that's why I'm just giving you this information for now. Okay, I'll not go in more detail, but I'll give you a homework. Okay, so one homework is learn more about. So this is a mathematics thing actually. Learn how to basically convert decimal to binary, or binary to hexadecimal. Basically, how do you convert some value from one number system to other between binary, decimal, or hexadecimal? Okay, we will need this information later in the course at some point. Okay, not right now, but yeah, this is a homework for now. So try to do it by yourself. If you don't understand, we have the doubt class on Wednesday. We'll go in detail on this concept there. Okay, so yeah, we are already around the time. I still have few topics to talk about. So we went into hardware, computer hardware completely today, right? So now you understand actually the hardware part of computers in detail, right? How the entire computer hardware works, right? So I also wanted to compare the complete the software part of it, but I think I'll need at least half an hour more, and it's already late, so we'll have some part of the class maybe tomorrow or on later this week. So whenever you guys suggest. Okay. So before that, let's talk about the assignments. Okay, so software part, I'll leave TBD in the notes for now because this is to be done. And then when you learn software, I think I already talked about how software and hardware work together, because when I told you how OS loads into memory and runs right on a computer, which is what I wanted to talk about in another section, where how hardware and software work together. You already understand a bit of software also, because I already told you about instructions and lines of code and all that. So it's just little more information that I wanted to give, but yeah, we'll cover these two topics later. Okay, so let's talk about the assignments now. So for the assignments, you'll have 1 week to do the assignments. Okay, so there's a lot of reading stuff that I'm giving you. Okay, so this is more for just consolidating your the topics that I gave you today already, right? But for the actual practical assignment, what do you have to do? Okay, so everyone has to install Linux on his computer. Okay, and he has to submit the screenshot once it's installed on WhatsApp. Okay, so what is Linux? How to install Linux? Let's talk about that. Okay, so again, Linux has a lot of different versions. So let's lock one version. Okay, so let's not go everywhere because everybody will get confused. So let's stick with Ubuntu 20 LTS version. Okay, so this every software has a version, right? Like Windows, Windows XP came, then Windows 7 came, then 10 came, now 11 came, right? Similarly, Linux also has a operating system called Ubuntu. So like Windows is there, similarly Ubuntu is there, right? And Ubuntu also has versions 10, 12, 18, 20, 22. I think latest is 22 or 21. So okay, so you have to install Ubuntu 20. So how do you install it? First of all, okay, you don't have to format your Linux, you don't have to do anything. So there is a software called VirtualBox. Okay, it is a free software. Just Google for it. I'll show you how to get it. So go to VirtualBox, Oracle VM VirtualBox, downloads. Okay, so go to, if you are running a Windows laptop, use Windows version. If you are running Mac, use Mac version. If you have Linux, then you don't have assignment. You already have Linux, right? If you are already running Linux, then perfect. You don't have assignment for this week then. Okay, so otherwise on Windows or Mac, I'm assuming you guys don't have Linux already. You have to download VirtualBox first and install this software. Okay, so what the software does is it will actually create a virtual computer within your computer. Okay, so now on top of Windows, you can run another operating system. Okay, so there are a lot of videos on YouTube on how to run or install Ubuntu on VirtualBox. Okay, so I have linked this video here for you. Okay, so just go and watch this video. Okay, sorry, it's not a video, it's a blog. Okay, so it tells you everything. What is VirtualBox? How do you install it? How do you set up? Okay, so once you set up a VirtualBox, you'll get something like this. Okay, some blank screen, and then you have to first download Ubuntu. So how do you download Ubuntu image? You go to Ubuntu website. So you say Ubuntu download image 20. Right, so you got here. you'll get a .iso file here. Okay, so desktop image, you got the ISO file. See, it's okay. This is very big, so let's go with a smaller one. This will not work. Okay, so let's search for minimal image. So I'm giving all these links also in the assignment only, so that you don't have to. Into 20. Okay, so this is like what 250 MB, right? So just copy link. So just download this file. Okay, just put this. Okay, I think in older course I was suggesting 16, but now I'm suggesting 20. Okay, so you can use this image to download. Okay, so once you download this image, you can go to this and you can follow these screenshots, whatever it has given. So you'll have to basically within the virtual box, you are now creating another OS, right? So you will go to file new, you'll give it a name, type as Linux, right? And you'll create a virtual hard disk. So from your hard disk, it will take some space, 20-30 GB, right? And it will create a virtual hard disk. And just follow whatever is in the screenshot, right? And just follow the instructions in this blog. Then it will ask for at some point it will ask for the image, right? So now here you are choosing the optical disk file, right? So you'll choose a Ubuntu image file which you downloaded, right? So you loaded the image, and then you'll just say start, and your Linux will start. Okay, Linux installation will start actually. So again, Linux installation steps they have given here. Read everything, try to follow everything, learn these concepts. If you are seeing something new on this, just Google around it, you learn more about it. Okay, or you can ask me also in the WhatsApp group if you don't understand anything here. Okay, so this is how you actually install Linux. So this virtual Linux will actually get installed in this virtual drive or virtual machine that is getting created within your computer, and then you'll have a running Linux within your Windows. Okay, so so basically you have to follow this blog. That's all. I've already given you all the links. So either you can use Ubuntu. Earlier I was allowing all these other versions also, but let's keep it consistent now. Okay, so I'm removing all these instructions. Let's everybody uh, should use just VirtualBox, and everybody should use the same thing. Okay, then people can help each other also. Okay, any questions on the assignment? Anyone?
You will be sharing the links to us, the assignment
Yeah,
questions.
so the recording and these notes, right? I'll be just putting them on the Dropbox, and yeah, within an hour or two, after the class, because upload will take, and that Zoom takes some time to actually for that recording to get developed. So it will take an hour or so. So once it's all uploaded, I'll share it on the group. Okay.
Yeah, thank you.
Okay. Any questions, anyone on this? Okay, so see, this is again getting your hands dirty, right? You will get uncomfortable. Mera computer kharab na ho jaye. Don't worry about any of those things. You have to just install a simple software, and you have to just follow a simple blog. It's that. If you focus and read everything carefully and do everything slowly, you'll go through it. Okay, and don't worry, group is there. I'm there to help you guys. Okay. So Linux is biggest fear, even within the computer science BTechs also, right? They all are afraid of Linux. But with first day in the company, they have to work on Linux. So if you learn this, this is very big skill actually. You can after the course, you can tell your computer science friends, yeah, I know how to work on Linux, and like they'll say, you're a genius. Okay. Any other questions, anyone? Before I close the class. Okay, so for the class, what time works? Same time tomorrow works, 10 p.m. for everyone. I think 30 minutes to 45 minutes I'll take tomorrow. Anybody for whom 10 p.m. tomorrow does not work? Now is the time to call out. Okay, I think it works for everyone. Then yeah, we'll meet tomorrow 10 p.m. then. Okay, and start working on this. I'll put some poll sort of just to monitor your progress, and you all know what happens if you don't solve your assignments, right? Your deposit gets lapsed. Okay, and the reason all these assignments are very important is because these assignments will build on every class. Each assignment will build up on the last assignment. If you don't do assignment 1, you won't be able to do assignment 2, because assignment 2 will actually use Linux. Okay, so if you don't have Linux, then assignment 2 you cannot do. And in assignment 3, I'll use something which will use something from assignment 2. Okay, so it can't happen that you missed one assignment in between, your next assignment will get stuck. Okay, so you have 7 days, like I said. There, I won't accept any excuse. Just अभी क्लास खत्म हो गई, 2 घंटे अभी जग के चालू हो जाओ. Okay. Okay. Any questions before I close the class?
Yeah, for those who are already using other Linux distro.
If
Like
you
I
are
already-
anything else, that is fine. I think then you can enjoy this week. You just go through the reading assignments.
I already have Linux Mint installed. So if you say, I can download the VirtualBox.
Yeah, if you have worked in Linux and you have a Linux working installed already with you, then it is fine. It should work. Okay.
Rahul, my laptop is pretty old. It's about 8 to 10 years old. I'm not sure if it will be able to install Linux.
Okay, so what is the configuration?
i3.
i3, it will work.
i3 it will work. Huh?
What is the RAM? 4 GB, 8 GB.
It should be 4 GB.
It will work. So when you create this virtual box, right, you can actually set key what amount of RAM and processor you want to give to the virtual image. Okay, so just set 1 GB, right? So if you see at this point, right, this is size. At some point, you can actually control key what. So just give 1 GB, okay, for it. So 1 GB will also work. So this is the hardest side, but yes, there's some toggle to control the RAM and the processor for the virtual drive. Okay, it should work actually.
Okay.
Okay, if it doesn't work, then we'll see what we can do about that. Let's try this for now. Any other question, anyone? Yeah, if 4 GB RAM means we need to select 1 GB. Yes. So basically, out of 4 GB, you are saying the virtual box or this Linux will take 1 GB out of your complete 4 GB. Okay, so yeah, this is the general rule of thumb, right? Whatever, if you have a 16 GB RAM or 8 GB RAM, just give 25% of that to this new virtual image that you are creating, virtual box in virtual box. So if you have 8 GB RAM, select 2 GB. If you have 4 GB RAM, select 1 GB. 16 GB RAM, you can give 4 GB. Okay, that way your computer will not slow down when you are running it. Okay. Any other question, anyone? Okay, thanks a lot, everyone. Then just one request I have, that if you guys can do some publicity about this course, because my effort of teaching you guys remains the same. If there are 30 people, 40 people, 50 people in this course, so I still want to admit more people if possible. So what I'll do, this first lecture I'll also upload on YouTube, and I'll also post it on my LinkedIn tomorrow morning. And just pass on this first recording with more people in your family, friends, whoever is interested in IT, and just see if you can like bring in more people. Okay, because the general, I'm not doing it for money, right? So I just want to help more and more people. So just try to bring in more friends and more people into this course. Okay, that is the only request. If you can post tune on your college group or your whatever WhatsApp groups you guys are part of, that I'm doing this course, and if somebody is interested. Yeah, so if somebody wants to join from second lecture, yeah, that is allowed, right? That's why I'm giving the I'm putting the first lecture on the YouTube so that they can watch and they can decide if this course is for them. And if they like it, they can join from the second lecture. They'll have to work hard, obviously, because they'll have to now complete the first assignment also in limited time. But yeah, if you do this thing within the next 2-3 days, still they'll have some time to complete the first assignment, and they will be able to catch up. Okay. Okay. Thanks everyone. Good night.
Thank you. Good night.